Today, my friends, we're headed into the world of high-speed connectivity. As data rates continue to climb and system designs become more demanding, we need interconnect solutions that can deliver exceptional signal integrity, flexibility, and reliability, with the ability to scale in the future without tanking our development cycle. Whether you're designing an industrial application, something in the telecom industry, a military or aerospace design, or even a data center, choosing the right high-speed backplane and cable assembly solution can make all the difference. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Anders Thelin from TE Connectivity and I explore how the Seabbot multi-gig transceiver platform helps address these challenges with a modular, high-performance approach to rugged, high-density connectivity. We also look at how this platform supports next-generation system architecture, improves design efficiency, and enables robust performance in even the most demanding environments. And before we get started, don't forget to click that link. There you can find even more information about this topic from TE Connectivity. Hi, Anders. Thank you so much for joining me.
Hi, Amelia. Thanks for having me.
Absolutely. Okay, so we're talking all about the CBOT multi-gig transceiver platform today. But first, Anders, what exactly is CBOT?
Yes, what is a CBOT? It's a new take on an optical transceiver. And so what we did here at TE is we started off with a standard SFP. It's a footprint that's widely known in the industry, and it's about the size of a thumb. Then we lifted the hood and we took out all the important pieces that you can see inside, and then we put them onto a ceramic and we created a light engine platform. This little light engine, we made one of them for the transmit and one of them for the receive, and both of these can easily fit on the tip of your finger. Next step is we took those little light engines and we put them onto a PCB and into a housing. That allows us to align a fiber to the active components, and now we have a pigtailed transceiver. And as a final step to complete all of this, we now use the known performance of our multi-gig connectors and eye of the needle contacts to connect the transceivers onto the PCB board. And that gives you the CBOT multi-gig TRX platform. And it just rolls off your tongue, doesn't it? That's what we just call it, the Seabbot.
It does. Okay, so Anders, can you give me a quick overview of this solution?
Yeah, absolutely. Like I said, it's a unique take on a transceiver, but it's a small footprint transceiver. And as with everything from our rugged transceiver portfolio, it's intended to be used for harsh environments. It's a pigtail transceiver, meaning that the fiber is permanently attached. We have a couple of options. You can go up to 10 gig. The real advantage here is really that it's modular. That's the key to all of this. You can use different versions of this CBOT to fit into different needs of your design, all without having to change the layout. But that's really the key takeaway from this product.
So it's modular. All right. So, Anders, what are the building blocks?
There's a few of them. I talked a little bit about the speed. You can choose between 4 gig, 10 gig, all the way up to 10 gig. But it works all the way down to 20 megs should you want to. We have different sizes, different heights. So you can see a full height. That's going to be roughly 12 millimeters above your PCB. And that will incorporate 2 channels, meaning a transmit or a receive. And then we have a half height version, which is 8 millimeters roughly above your PCB. And that's just the 1 channel. So you can choose between the heights. You can then also choose between speeds. You can choose between multi-mode or single mode, at least for the receive side. And in the future, you'll have single mode transmit as well. Exciting thing about this is you can choose if you want transmit or receive. Typically, a transceiver is you have 1 channel for transmit and 1 for receive. But here you can opt to have double transmit or double receive, whatever fits your need best. We also have the cable and the termini. Since this is pigtailed, that's user defined. And you as a user, you get to choose what cable you want. Typically, that's a 1.8 or 2 millimeter cable, but you also get to choose the termini. We can terminate it all here. Traditionally, it's single fiber cable, but we can also do MT. If you want to bundle a lot of these Seabotts together into one MT, we can do that.
So, Anders, talk to me about the advantages of this solution.
So generally speaking, modular approach means you open a couple of new doors for designers. The first thing you might think of is it's going to be easy to replace these parts. You get a scratch on a fiber out there. Instead of throwing the whole transceiver away, now you can just replace one of these blades should that be damaged. It makes for a very compelling and easy way of replacing parts. But of course, it also makes it possible to upgrade, like from 4 gig to 10 gig when you need it. You can adjust and expand your capabilities, and you can do all of this without changing the layout or your PCB. So with this, you can reuse tooling, you can reuse technology and processes, and this should all lead to faster path to qualifications. And at the end of the day, it should reduce your costs and just make your workflow easier.
All right. So, Anders, also talk to me about the performance and reliability aspects of this solution.
For performance, we do have a 10 gig base SR compliant product. We also have 4 times fiber channel. Those are the 2 typical compatible eyes that we work with. As for power consumption, that's an interesting takeaway with this. We have very low power consumption. This is a simplified version of a transceiver. So the power consumption is typically 130 milliwatts per transceiver. That's 1 transmit, 1 receive. So that, of course, is a big plus for your swap. Signal integrity, I mentioned before, we utilize the multi-gig iodine needle contacts. So the signal integrity is great. It's proven out between the board and the transceiver itself. As for environmental and reliability, these parts are designed and operate at -40 to +85 case temperature. We've run several qualification tests on them, which includes the 883 vibration and shock, all the shock and vibes and the thermal cycles you can imagine. The housing is screw mounted to the PCB, should that be needed. And all the individual Seabbot blades are potted as well. There's also an option should you want additional cover on to cover your connector from dust.
Okay, so what's the typical configuration?
So this is a pigtailed transceiver. So that means we have a transceiver on a connector. It has the fiber sticking out of it, and it's got a termini at the end of it. But typically what we see from customers is that they go beyond that. They keep adding the insert and the connector to that. So there's a picture where we show how a typical Seabbot looks with the termini, but we can also provide the insert and connector, should that be circular or rectangular, however you want. We can provide the whole end-to-end solution. And we see a lot of that need, the whole end-to-end solution, when we look into the typical applications. It's really anything with Ethernet or InfiniBand, but typically we see in-flight entertainment and any ARINC 818 applications. But really what's especially interesting to this product is when there's an unbalanced system. And what I mean with that is when there's more TX than RX or more RX than TX. That's transmit versus receive. If you got more transmit than receive in typical quad or typical offerings that are out there on the market today, you're forced to use whatever is provided. For the Seabbot, you can choose yourself. If you want multiple transmits, you can do that. If you want multiple receives, you can choose yourself. So that's another advantage of this modular approach that we see being utilized in many different applications.
So, Anders, what else can you do with this technology?
Yeah, there's a couple of things, and don't get me started. If you allow me to dream, I can stay here all day. But really, I touched a little bit on it earlier. I talked about some of the things we have in our pipeline, that we have single mode for transmit. We also have versions we're working on for media conversion. We have certain protocols for 3G SDI. We can talk about RF over fiber solutions, all in the same footprint. So it's expanding this family of Seabbot, giving users a lot more options in the same footprint. But you can also take the light engine that we talked about earlier. Think about what else could we do with this? What else have we done with this? We can use that light engine, put it into different types of packages because it's so small, doesn't consume a lot of power at all. It's very versatile. So we can put this into active contacts. We can put it in custom housings for pressure tolerant versions, and we can design whole new other platforms should we want to.
All right. So is this available today?
Yes, it is. We're selling this today to multiple customers, but just recently we're also hearing the need from the market that they want to try this out. So we have designed an evaluation board. What an evaluation board is, it's a PCB with SMAs on it for your signals, as well as a 10 gig transceiver. It's a multi-mode transceiver, and it's terminated LCs. This is really for your lab environment so that users can try this out and verify the performance for themselves. So we sell this through distribution today. You can find it there. Of course, to support all of this, you can also find a lot of data sheets, everything from simple 2-pagers to 14-page technical documents that you can read till your heart content. And should you need even further support, there's plenty of reference documents through either distribution or directly through te.com.
So how does this solution work with other products from TE Connectivity?
So this plays into TE's mindset of end-to-end solutions. What we showed now was a transceiver, an optical transceiver that goes on your board. TE is very well known for our connectivity, meaning circulars and rectangulars, as well as FiberFlex solutions. But now we have an active offering as well, where we can generate light and receive light. And we can couple this together with FiberFlex, with card edge connectivity, with circular connectors, and the harnesses that we're already offering. So it really turns TE to an end-to-end solution provider.
Fantastic. Well, Anders, I think that's all I have time for today. Thank you so much for joining me.
Thanks for having me, Amelia. Appreciate it.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from TE Connectivity. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EEJournal.